Thanks for an introduction. So first of all, I have to mention that from previous work we already learned that we are able to translate our kidney pathology images from one stain to another stain. And we used it for domain adaptation. So we wanted to segment an image for a stain where we don't have training data, but as we had training data for a different stain, we were able to translate from one domain to the other. And then we had the data, and so we were able to perform supervised segmentation. Now we used this idea to, so the idea was, why not using all virtual stains we were able to construct in order to improve segmentation accuracy? So this is a proof of concept study. We tried, so we started with our kidney data, we started with a PES image data, and we augmented the domain. So we generated several immune histostains, and then we processed all the data. So after generating the virtual stains, we concatenated the images and we merged them. And finally, we trained, or we did not really train because we used a very basic segmentation method finally to perform a segmentation. The idea is to use a very basic method which is completely unsupervised, and we just wanted to see how far we can go with that. So what did we use for translation? Actually, we used a very common method, so-called cycle gun, which is used in order to make horses out of zebras or to make winter images out of summer images, for example. We applied the method to histology images, and what we got was quite, for us, quite amazing, because the images looked quite real. And not only real, they also looked similar. So if we make, for example, a PES image out of a Col3 image, the image looks like an image would look like if we really stained it with PES. So what did we do for our paper? So we used our real pass image, which we started with. Then we created, for example, 3 IHC stains, which are corresponding to our original image. So if you look at the images, they look, for us, they look quite realistic on the one hand and also corresponding, which is even more important for us, because what do we want to have? We want to have additional information which helps us for segmentation. So in the next step, we used all the data and more or less merged the data. This is just a visualization. So here we merged the first 6 channels of PCA, and we created 2 RGB images out of that. So this is not really what the computer sees, but it's a nice visualization, and it shows us how much information is actually available in our data. Then we considered 4 different segmentation tasks. If you're interested in that, I invite you to join my poster, because we don't have so much time. So finally, the conclusion is it's a nice proof of concept. So we found out that scores during unsupervised segmentation actually improved. However, the tasks are not so easy. So the tasks are quite difficult, and our very basic segmentation method is definitely not good enough to provide a very high scores during segmentation. Well, we need to investigate more advanced methods for sure. We could also focus on unsupervised methods, but we have to apply post-processing for sure, or we investigate neural networks, which at the moment we already did. So if you're interested in that, please join my poster. Thanks.
Questions? So when you generate these fake or synthetic images, was the evaluation done visually, or did you do other evaluation methods?
On the one hand, yes, evaluation first. If they're to investigate if they are realistic, we did it visually for sure. But finally, our real evaluation is to consider segmentation accuracy. That's what is important for us. So that is our evaluation.
Okay, thank you very much.